Hello, I'm Ken Pugh, and this is Danil Suits, and we're going to attempt an experiment in applying errors to a regular kata, the Mars Rover kata, and seeing how the design changes when you start dealing with errors. Most katas tend to not deal with errors. This is an experiment to see how the code itself and the design might change for errors. So first, let me share my screen and showing you the new, I'll call it scenarios. And this happens to be written in Gherkin, but we'll be doing it in JUnit. The normal scenario for the Mars rover, and you can check online, we'll also make this feature file available to you, is we give it a series of commands for one rover, and it's going to output its position. So as you see underneath that, this first scenario are the actual strings and the string coming out. Under the commands are the meaning of those commands. For example, we have size. That's we go 5, 5. That's the size of the map in XY coordinates. We have the starting point in XY coordinates and an orientation, followed by a move. And that's left move and so forth. And we'll show that in just a little more in a moment here. So let's just go over the scenarios themselves as is, and we'll talk about what we're going to cover and not. So we have this size command, and each of the two parameters for X and Y has limitations on it, i.e., it's got to be between at least 1 and less than or equal to 100. And so we can say, here are the values valid or not? And 1 is below minimum and above minimum. And so now we have the command to set the size. So our command is 5, 5. That gives us an X size and a Y size of 5 each. Now, if we were testing for errors, we could have additional commands here, such as 1, 5 would be perfectly fine, but 0, 5 would give us size invalid, okay? Because the X is below minimum. And you'll notice we have all the other possible combinations there. For the starting point, and we are going to show this as our one of our examples. We have 4 directions, north, south, east, and west, and everything else is invalid. So now, given our starting point, here's our command to set the size of 5 and a 10 for the X and the Y. In this next command, we're simply going to try it. That's the normal thing. That should all work because that actually came from our workflow. And then we have our possible errors. The fact is that we've got an invalid starting position because it's beyond the size of the map, and an invalid starting orientation because Q is not a direction. Let's take a look at the moves. We've got the moves, M, R, and L for forward, right, and left. And now that says, here's our move that we had in our workflow command. That simply breaks it up. Here, if our move was just Q, that would be an invalid move. Or if Q appeared between 2 valid moves, it's still invalid. So now we've got making a single move just shows us, here's our move. This is our size and our initial position. If we simply did a left, then we ought to be facing to the east. Okay. Here's our business rule for make a move. Based on an initial X, Y, and orientation, when we move, this should be our new X, Y, and orientation. Well, we're going to put one more thing here we'll demonstrate, which is when we make a move and we're at the edge, we don't want to move, we want to return an error. that indicates what edge we're at. And here's some of the combinations that are possible. So what we're going to start out first is with, we could do this for the size command, but we get into the same issue. So we're going to do it with setting the starting point. We're going to have, here's our size command, convert. And when we convert it, we want to make sure that the start position is on the map and the orientation is correct. So I'm going to start sharing and I'll let Danil take over.
All right, so let's get this up where we can see what we're doing. So the first thing that I'm going to do, of course, is run a quick execution of the test suites that I already have in place to make sure that the code is currently passing all of its tests. We have 2 tests that are implemented right now. One is based on the original interview question from ThoughtWorks. The other one that we did as part of our pregame exercise was simply to make sure that the happy path worked the way that we expected it to. And sure enough, it does. So we've got something to demonstrate for you live today. So let's look at first addressing a new test with the new extent that is going to continue to occupy the happy path. That is, we're just going to make the plateau a little bit, y dimension is taller according to the domain rules here. So public void, oh goodness, verify happy path on taller plateau, which should be spelled correctly just for our own sanity. And the plateau test for the happy path test looks pretty much like the one that we were running already. The only thing we're doing is we're making the plateau a little bit wider. We've made one single change. For the purposes of this exercise, I don't think we're going to worry too much about trying to parameterize all of our tests. We're just going to keep things nice and simple and straightforward. And we expect this test to pass immediately on executing it. So let's try and first see if that's true.
So I'll just make a comment here. The reason I did 5 and 10 is I like to give different values to my coordinates just to make sure that they're being picked up properly. Otherwise, it would be possible with 5 and 5. The 5 for X could have gone into Y and the 5 for Y could have gone into X. So that's why I simply use different values there.
All right, so the assert tells us that everything is working and we can do a full run. Whoop. Come on, wake up. Full run of the suite. Don't set a breakpoint. Oh, let's try that again. Control-Shift-D is the magic command to run everything. Run everything for me. There we go. So all the tests are happy right now. Depending on how much confidence we have in the test harness and the implementation, we could go and inject a fault to make sure that this test fails and then revert the fault. Let's save some time and assume that we know how to type correctly. So the first of the failure scenarios is going to be similar, and I'm going to pull up that code again to not doing size invalid. We're looking at invalid starting position. So we're going to use a 410E to start with, okay? And so we need a new name for it. Verify error returned if rover off top of rover starts off top of plateau. And right now, I don't know what it's going to do, but we know that that's not the answer we want. So let's pull up that original error code that we looked at. So one thing I want to throw out here as we're looking at this is that there's potentially a legitimate design question here in terms of, are we really putting the right information about this error in the right place? For instance, if we were writing a command line application, then we might want this error to be written to standard out rather than to standard error rather than standard out, treating it as a diagnostic rather than as an output. And that might get harder to do if we're mixing our error signals and our output signals together into a single output. We would need to write some sort of a grep that's smart enough to figure out which are the errors and stick them in somewhere else. So you might legitimately sit back and say, Rover output returning a bunch of strings like this isn't the right thing for it to be doing. We need something smarter. We are not going to be exploring that avenue today, but I did want to admit that we're aware of it as a thing. So this test should absolutely fail because nothing in my code knows about this string at all. So let's just do a quick run of everything and try to prove that that's true. And sure enough, test with a really long name fails. And sorry, I can't see what's going on because it's under a Zoom toolbar, but it appears to say array contents differ, blah, 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 which is great. That's the error that we're expecting, which shows that we expected invalid position, and it actually moved the rover around just fine with those commands. So we need to change this up. When I do TDD and I'm in the red, my metric for how good I'm doing at TDD is that I get from red to green in the minimum amount of wall clock time. Making anything look nice is something I can worry about during the refactor step. Now, because I'm aware of what code is written, I happen to know that this 410E string is unique in the code base. So I can do something like if (410E), which is just a string literal right now, equals lines, and that was the third line.
That's the second line, right?
Should be, yes, you're right. It should be the second line because it's the position, not the
Right.
command, or sorry, it's the position and not the program. And we're just going to take the hardwired string from the test. And that's not right because the signature doesn't match. I instead need something like string error equals boom. And then return error. And so the compiler is going to be happy. And we run it. Well, we run it. There we go. And ta-da, the test passed. That was, what, 60 seconds, 120 seconds. That was a pretty pathetic effort on my personal scale for wall clock time. But we've got the basics. We've got a test in place where we've verified that it catches at least one kind of mistake we might make. We've verified that it correctly identifies the correct result, we're ready to try and turn this into something that isn't a dreadful embarrassment of an implementation. So what I normally do at this point is start refactoring toward what I think the design ought to look like. And I'm trying to do that without breaking any of the existing behaviors. So again, we only see one test here. Let's do a sanity check where we actually run all of the tests and try to make sure that nothing is broken. And that should certainly be fine because none of the strings match here. And okay, we're good. So what's going on here? Why is this position invalid? And in our case, the position is invalid, not quite just because this string exists this way, but we've got something like int coordinate y. I am improving on the fly. So the first thing I'm going to do is just drop everything into a scope block in Java. So any variables that I declare in here are not going to suddenly cause other things to break on me. Once I've got an implementation that we're happy with, I can back those out. So I'm going to look at something like int rover y position equals 10 and int plateau y max equals 10, where this 10 is coming from the instructions or the rover positioning command, and this 10 is ultimately going to be coming from the plateau sizing command. And then our logic looks something like if, oops, I've already got an if, rover y position greater than or equal to plateau y greater than equal to plateau y max, then return the error. And this is going to be an abysmal failure as written because it's going to break all my other tests. So I still need, for the moment, that 410e that equals lines 1. All right. And so all this should still be working. Come on, wake up. And so what I'm working towards here is an approach that Alexis King wrote about in 2019. I'm thinking more about parsing the data than validating it. And so I'm sort of working towards a section where we would have a branch at the top that says good message in or bad message in, and then we'll go from there. So, all right, we've got passing tests, nothing is broken. So rover y position here is actually something like, well, I have some string parsing code down here at the bottom. So let's take a look at how I did it there. I just did integer parsing. Okay, so rover y position here becomes integer parse int of 10, and likewise integer just parse int of 10, and it looks like I ended up with an unsigned int up top, which is not what I want. So let's put that back. And I should still be okay. All right, so I figured out where the rover position and the plateau position, what those values are coming from. Now I need to start working backwards to the actual source material for it. So this rover position is actually coming from something like string rover position equals lines 1.split.
Could you have reused your, or extracted out your parser and just used that or not?
I think I could in time.
Okay.
There were some concerns I had about which error scenarios you were going to end up throwing at me, right? Ultimately, all of the parsing code should end up together, right? It's going to be an encapsulation or remove duplication. For right now, I'm just sort of evolving toward it to get there. Right. Also, we would have to deal with the fact that the parsers would need to worry about things like sequences of strings that aren't actually convertible in integers, which the initial parsing code didn't have to because it already knew that it was in the happy path.
Right. Yep.
All right.
Okay.
So now this 10 is actually the second element of the rover position string, which is index 1. And so we expect this to work. And ta-da, it still works. So we're still getting the error message back that we're supposed to. And so we can play the same kind of game here, right? And I'll do it a little bit slower this time just to show where everything is coming from. We have plateau description, or short description. We can always fix the error names in post. And that was something that looked like 5 and 10. And then we say, okay, all of you junior developers who are watching this and going, yeah, he really sucks at typing, take that to heart. You should learn how to touch type better than I can. It will serve you well to be able to think and make code appear on the screen at the same time without extra errors.
And if you're an older guy, you might have even taken typing in high school.
Yeah, sometimes I give away that I'm older than I look, and sometimes I give away that I'm younger than I look. It's an interesting twist. So, okay, that's really where the 10 is coming from. We're going to crack apart the plateau description into 2 pieces, and then we're going to parse it as an integer and see where we go from there. So again, quick check. It's really going to be shocking if this thing compiles, but the test doesn't pass. But we try and prove it anyway. I really feel like TDD in languages that are quicker than Java become a lot more effective. Gary Bernhardt talks about being able to run all the tests in 300 milliseconds. My JVM can't even start that quickly. So the test passes, and now we go back to looking at where this 5 and 10 came from. And that was really a line 0 split on space. And we run that test again, and sure enough, it's going to do exactly what we expect it to do. But at this point, I'm going to do just a little bit of reorganization here. At this point, we're actually checking the input data from the test that we've been given. And in this particular instance, the only case where we have a Y position that's outside of the plateau is this one particular test we're looking at. In other words, if I comment out just this if clause and turn this into a block that always executes, everything should still work. Won't this be interesting to find out? And sure enough, it does.
All right.
Right? So we're getting warmer in terms of what should these checks look like. Now, different rules here. We know logically that we worry about things like the rover position being greater than the plateau min, but we don't yet have a test to check that. So there's some potential for back and forth in terms of how much you want to do as part of this bite versus how much you want to have other tests to back you up. I don't have a great sense for where this is going right now with just this one branch in, and I prefer to have additional tests in place when I'm injecting additional branches into the solution. And I don't see a way to hide the branch somewhere in, say, the standard library, like the way I might with a map. So at this point in an exercise, I would probably just clean up this comment. We don't need it anymore. I'm gonna leave the braces because we're still in the problem of trying to make the parsing look reasonable. And I'm starting to think about moving on to the next test. You might categorize this as a triangulation exercise. I don't know what the final design should be, so I'm going to throw a few more failing tests at it and get them all working together and then see if a better design reveals itself as I'm going along. So let's see if we can find that next one. And we have an invalid starting position based on a 5-4E. And I'm probably going to change this a little bit. So we already looked at an invalid position in the Y coordinate. This has got an invalid position in both, which is a test case that we should probably have at some point.
No, it's the 4 is good for Y.
No. Oh, sorry. 4 is good for right. We're at a 5-10. I keep looking at the wrong syntax. Okay, that's why you pair with a partner, folks. All right, so we'll do a 5-4, and that'll give us a high X. I don't see anything with a low X or Y here because those are negative instead of positive. I think that's probably fine for now.
Yeah, we could add, oh, thank you. We should have had those in there, but well.
It's also useful to have a pair partner when you're designing test cases. Yep.
Yeah, exactly.
All right, so again, I'm just gonna replicate the test. And what's my test name here? Off right of plateau. And we're looking at 5-4E was the test, if I got that right, Ken?
Yep.
Okay. And so nothing in our new validation logic should change this. So if we run, we should just get some location on a grid that's not necessarily legal.
Excellent. A failure. I love to see failures.
All right, great. So same kind of game. We know this string happens to be unique. It doesn't match the one we used earlier, which is why I'm not reaching for the plateau description. So we'll switch back to the rover code. And it's going to start out looking like the same kind of cheat that we did before. if paren equals lines 1. Oh my goodness, look at all this extra duplication. We're just going to copy paste this thing. And then guess that that's actually going to solve the problem. Come on, test runner, be faster than that. Green bar is 5 for 5. Okay. So the first thing that leaps out at me from that copy paste is, oh, wow, this thing really ought to be a method that's easier to copy paste. So I'm just going to say start invalid. Let's call it an error, just a error start invalid position. Do I want to replace that occurrence? Yes, and that's why we have all these extra tests lying around. And IntelliJ went through this thing down here near the bottom of the file somewhere. Run and prove that everything was okay. So what I'm starting to see here is the notion that there might become more generic versions of dealing with an error like this. And we're certainly going to see it when we start looking at orientation, which is, we can essentially project already the fact that parsing errors, whatever the return mechanism of them is going to ultimately be, are likely to share the same mechanism here in terms of them all sharing the same data structure. But if we were overly invested in objects already, then they might be all sharing the same object type. So, okay, this is the same game that we saw before. So I'm gonna sort of cheat the same way. That is, I'm gonna come in here. How do I want to do it? Let's do it in parallel first. So I'll borrow this code. The rover position code is the same. The plateau description code is the same. For my own sanity, I'm going to put the plateau description up on top. Here we're looking at plateau max x. And that's going to be an integer parse int of plateau description 0. So another thing that we might notice as we're going along here is the fact that, oh, we've got all these magic numbers that are falling out of the parsing. We could reasonably say that the we could easily say that the schema of the input messages is a thing, and possibly a thing that changes. And in that case, we might want to group all of those magic numbers and the production rules associated with them all into a single module that knows everything there is to know about how to take these strings that we're getting as input and turn them into the real data structures that we're going to be working with. So that's going to be rover position. And again, x is 0. And then we play with the game where we say if rover x position greater than to plateau max, and that should always be true. So let's see if it's, first make sure that it continues to pass the test that we already have. 5 for 5, so we're good. We ought to be able to take out this conditional, just leaving the block in place. and we're 5 for 5. And so now we should be able to take this chunk of code here. Actually, I'm going to do this a slightly different way. We should be able to take this entire chunk of code out of this block entirely and replace what we have there. Have that still work. And we're 5 for 5, so we can get rid of this. All right, so that's gotten us to the point where we're sharing the parsing logic. We're still only checking this one row. I don't think we're going to go into it for this exercise, but these kinds of checks are something that we would want to do for all of the rovers in a given problem set, not just the first one. Similarly, if we were going to be experimenting with lowercase numbers, we might want to do something there. One could reasonably start looking into should that parse be smarter, and should we be sharing this call to the error start position here? Should all of these checks be part of a single predicate that just takes a bunch of arguments and gives us the answer as to whether everything is ready to go? I don't think we need to push that far. We can do a little bit of grouping to make things look a bit tidier. That is, plateau X and plateau Y go together, and similarly the rover positions do, and this indenting is driving me nuts. So come on, reformat for me. No.
I hate that.
Goodness, I'm on the spot. There we go. Look at that. I'm on the spot and I can't remember my keyboard shortcuts. All right, so if we arrange it this way, we can really start to see, wait a minute, these are the same structure. But I don't think we necessarily need to push that hard yet. I think it's going to be a bit more interesting for us to look at the third of the failure modes. So let's pull that up again. And that was here in the feature file. And now we were looking at 4.4q.
And I just picked that out of the air. It has nothing to do with any current,
Yep.
any current issues.
All right. So if rover starts with invalid orientation, where invalid here really means something like, hey, we've got an RFC that describes rover messages, and that's not allowed by the production rules. And the error message is a little bit different in this one, so let's make sure that we get that right. And the position was going to be 4.4q, so we've got that. And we try and run, and this should instead actually return us a position. No, this is probably going to make a huge mess because the logic doesn't know how to, the existing logic that knows how to handle the happy path doesn't know what a queue is. And so it's not going to give us anything useful there. So sure enough, no pointer exception. Okay. So good news is that the test fails. Bad news is not quite the way we intended, but we'll fix that right away. So playing the same game, just sticking in a guard clause. If 4.4q dot equals lines 1, return, whoops. We already learned this lesson once. So string boom error equals And the error should be the same thing that's in the test. So let's just grab it. Let's stick semicolons where they belong. I did. Never hurts to check IntelliSense before running the tests. And ta-da, we got it right. So let's step back and think about where this is coming from, really. That is that Q. Well, what's really happening is something like if left, right, move, find index of Q equals -1. And so here I'm just reaching for simplest thing that could possibly work. I happen to know off the top of my head that I can look for strings inside of other strings and that's going to work. And so we go with that. A slightly better way to do it might be to do something like, where is my operations code? As it happens, my implementation already has tucked away a map that knows what all of the valid keys are. So I could just compare the string, whether or not it's a key in this map, if I were willing to refactor the map around. But let's, oops.
Would that be the simplest?
Beg your pardon?
Would that be the simplest, just to make that map accessible? And then we can use it here.
Yes, it's not entirely clear to me yet where the map belongs, but that, among other things, suggests that it's not where it is for any particularly good reason. So we can do something like pull it up here. Everything in here right now is static as it happens, because there doesn't seem to be a class anywhere yet. So we're looking instead, if not instruction set dot contains key. Ooh. Can you actually see the opaque hint that shows me that the tests are initializing? Oh my goodness, and I broke all kinds of stuff when I did that. Isn't that interesting?
Whoa. That's weird.
So that's why we have tests. Because that refactoring looked like it ought to be perfectly straightforward. I wonder if it's that. If we were doing test commit revert, of course, we would have to start this whole refactoring over again from scratch. And if those tests didn't pass, I was kind of liking that as an idea. But here we go. All right. So if instruction set contains Q, so where does that Q come from? Well, that Q is really this rover position split again, and then rover position 2.
Yep.
Give this a quick run. And it all works, and now we can verify that this new clause that we've put together actually works for all of our inputs because it's ignoring most of them. And it doesn't. What happened here?
Oh.
What happened there? So every test is failing because that must mean that my if clause is wrong in some way that I didn't think about. So let's think about what's going on there. So that's still a map. So being confused, I'm gonna try something a little bit here, which is what I want to. I'm going to go back to looking at that earlier thing, index of over position 2, if is equals -1. Because both those should both be either true or false, whatever is going on there. So that's a phantom. Okay. Come on, pair partner, what am I missing here?
That's a good question. Why did you just make an, because I'm always a separator, just give me another string called rover orientation equals.
Not sure which question you just asked.
No, I'm just asking between the two. I always separate things out.
In terms of formatting?
No, no, just after rover position, come down with a new line that just like your lines before. No, before that, one up. Right there. Give me a string, rover orientation equals rover position 2.
Right. Why not do an extract variable?
Yeah. Let's keep it. I'm one who, whenever you repeat an index twice, means you actually should give a name to it. Okay.
Where are my new to presentation mode? And I'm not sure how to. There we go.
Yeah.
All right. String error, invalid orientation. So if we run this.
Oh, it still passes, which means that both of those things are true.
Yep. And that's what we expected because we've still got this guard clause in place.
Q on there. Okay, take the guard clause.
So we take the guard clause off to find out what's going on.
Ooh.
Array lengths
Okay.
differ. Right, the array lengths differ because we're just coming in here.
Because we're all right. I think for some reason, can you just put a debug on rover orientation? Let's see what that value is that it pulls out of
We
it.
certainly can.
Because that's what I'm thinking, is that there's something. Rover orientation is Q. Okay.
And that means LMR, blah, blah, blah. Yeah.
Instruction
So-
set is 3. Just, yeah, okay, so step 1, past that.
All right, if not, rover instruction contains key. All right, so this is still the first test, and this is all doing exactly what we expect.
Right, so it's actually gotten to that statement.
Right, but we're in the test where we expect it to. So here's a test where we don't expect it to. Right, LMR. So down here in the debug window, we can now see based on the lines input that we've switched into a different test. All right, so this should skip because the problem is I'm using the wrong. Problem is that I'm an idiot. Okay, so orientations are cardinal compass points. North, south, east, west.
Right,
My
right.
instruction set is commands,
Oh,
left,
there you
middle,
go.
right.
Oh.
So that's why instruction set doesn't work as a potential answer. North, south, east, west.
Yep, there you go.
Okay, and just to prove things out here, we'll just comment out this.
Coming out that.
Whoops. I'm still learning presentation mode and it does not like me. So, getting a quote. There we go. Run that. Stop and rerun. There we go. Parsing. I'm feeling lucky. There we go, 6 of
Okay.
6. All right, so let's get rid of the unnecessary comments here.
So you don't have a map. You don't have a map for north, south, east, west. Then.
I do not.
Okay.
Run it again. And we're 6 for 6. So there are 2 things here. One is to play the parallel structure, error, invalid orientation. And keep original signature, please, for this, just for now. And then, okay, we're in this world where we've got the parsed rover position again. So let's just grab this code here. And we can arrange it a couple of different ways, but keeping the initialization of the rover orientation value near where we're using it is probably a good idea. And this code can all go away now because it's not actually doing anything. So we'll comment it out to check that first. And we should be 6 for 6 still. Here we are. And so we delete this code that we no longer need. All right. So again, we've got bits and pieces. We've got the shape of the branching logic. There are some things we can do to tidy up. IntelliJ wants to suggest it contains refactoring. So we take that suggestion under advisement, see what it gets us. We're aware of the fact that these error functions are very similar and there's some duplication that we could manipulate there if we decided that investment was worth it. One could also reasonably say that this rover position really belongs up here with the other parsing of that line. You could imagine a world in which we pass in a string and we get some sort of an object or a data structure or a tuple back that has these three values in it, in which case they'd all sort of be initialized together.
Could you, does IntelliJ have a refactoring to take those three lines and turn it into that or not?
I don't know. And I'm not confident that I can find them in.
If it doesn't
Yeah.
get you a suggestion.
If it had magically said, hey, turn this into something useful there, then I might have tried it. But I don't think that's easily discovered in a Zoom session. Right. We do have some reasonable separation of what's going on here. Other possibilities, as opposed to doing an early exit kind of thing, we might look at parsing as being something that returns a result and then branching on the kinds of behavior that you get based on the result that you have, or passing something into it to say, much like you might with a monad, passing in a function to it saying, hey, if you are a healthy result, then give me a something. If you are an error, then give me a something else, with some sort of polymorphism in place to determine which of those things is going to happen, right? In other words, we could take these branches that we've got here that are really technically part of this algorithm that we've implemented, and instead move them off into a dedicated parser that uses the branches in object creation. And then with those objects, you've got all just straight lines of code that do whatever they do.
Okay, let's just go down to your parsing that you had before, just for your normal parsing.
Yep. So in the case of the happy path, we really only have to look at so far in the happy path, we don't actually have to look at the plateau at all. So that just got skipped entirely, right? The parsing for working with the rover initial state was done using an object. So we could do something like grabbing this new state object here and sticking it in here. So let's do this. So right now we're not actually doing anything that changes the code, because this is just a new. We're in a block, so we don't have to worry about the names of anything. We can see from IntelliSense that this variable isn't being used anywhere. And so these things would now become, if rover state X, if rover state Y.
And now that positions us where you can have a method that says get rover state, and you just pass it line sub 1.
Yes.
Yep.
Yeah, so static states from input string raw. grab that same kind of logic. So split, and then after that, it's the same thing. We've just changed the variable name. So, except instead of holding on to it, I'm going to say return. And then we shouldn't need any of this anymore. We're just going to do lines 1.
From new state from.
Yep. From input. And that was enough work that I want to check it.
Yep.
So logically, this sort of works. I think it's a maybe. A lot depends on whether or not you think this state object that we've created here allows the consumer to assume that certain invariants of the data are being enforced previously, right? A consumer might reasonably expect that state orientation is always going to be one of the 4 allowed values, but that's not true here because we haven't actually done the validation yet. And depending on your designs, since this is a state, we don't really have a way of returning an alternative that is a parsing failure. So we would have to look into something like throwing an exception and then adding exception handling in the client to deal with those cases where this raw string that comes in isn't actually conforming to the schema.
Or you could return a null state using the null state pattern.
Yes, we could do that.
You know, or
potentially if state were something with an interface where that interface would support alternative spellings to handle errors, now you're starting to look like a parser as opposed to something that just assembles data into a data structure.
Right. So you're right on the orientation. So we could throw the tests in here, i.e., so that we will always, from input, we either are going to get a good state or a null state. So in other words, now we have a purpose for this object. It could do the validation of the object.
It could. Again, that's the kind of thing where I want to bang my head against the design for a bit. I don't think it's as easy as, yes, we can, therefore that's the right choice to make, right? Message parsing is something that gives you, yep, this was a valid message, and here is an in-memory representation of that fact, or something else. And here's an in-memory representation of that. And so I think it's important not to confuse the value object, the thing that can survive the happy path, with the parser that produces it without really understanding the consequences that are going to arise from that.
I well appreciate your point. I'll just mention that my approach is, if I am creating an object from input, my rule at least is, if it's improper, that's the spot I throw up my hands. I say, I'm sorry, the input is bad. The job of a value object or an abstract data type is to not allow bad attributes inside.
And there is a long and subtle debate on that point to be had, probably not as part of today's screencast.
Right. But if we took that approach, then we simply put everything inside of here of
Absolutely.
all the validation. And the other thing then would be, it will also, does state have a 2-string on it or not?
Only the built-in one right now. I didn't need it, so I didn't add it.
Okay, because I also have a 2-string on all my value objects or ADTs that say, okay, here's what the output looks like. You don't have to look inside. I'm going to give you the output you like. And obviously, if you have 4 different formats for output, it would be state's job to say which one.
Right, and that is in fact one of the kinds of concerns that I have when we're starting to work through the boundary of parsing versus the value object. There is nothing in the domain logic, so to speak, that's associated with Rover state that really cares or needs to be tightly coupled to the different kinds of serial representations that you might have. In this case, we happen to be using really simple strings and a really simple string array because that corresponds reasonably well with small inputs off of a command line. If we were dealing with HTTP, then we might be looking at instead at application form URL encoded key value pairs that need to be chopped apart. And is it the internal value object in the domain model that needs to support all of these alternative parsing mechanisms versus we have separate modules that you plug in when you need them and you don't have to drag everybody else's baggage with you?
Oh, I will agree with that. Okay. I mean, if you have 12 different types of inputs, I well agree that now you've got to figure out, should we have the HTML parser stuff and the XML parser and the JSON parser and the who's what's it parser? Absolutely. The only thing that I typically do is a string, parsing a single string representation. And I'm going to call it that hits 80 to 90% of the needs of things. But yeah,
and I think there are a lot of cases where that's a reasonable call to make, and potentially even, in terms of a code review, I'm certainly going to bless that if you accompany that with an architectural decision record that says, this is what we considered, here's the context we're in now, we're taking this approach, well aware that when we're catastrophically successful and have to support 2 different input formats, we'll change it.
Right.
We're accepting this technical debt on purpose. Okay, great.
So I think we said we were going to do this for an hour, and we just wound up to about an hour. So I'm going to ask just one more question. Rover orientation. I tend to, when there's a fixed number of things, automatically turn it into an enum, because it's like those are the only values. And what that also then prevents is switching a string somewhere else, and I don't have to do a lot of string manipulation. Would you convert Rover orientation into an object of direction type, where direction is an enum with north, south, east, west?
It depends. Let's talk about what it depends on.
Okay, good.
So one of the realities of this problem and most TDD exercise problems is that they tend to anchor themselves in stagnant domains. Rover message formats have not changed as a standard since ThoughtWorks came up with this interview problem 15 years ago, something like that.
Okay.
Right? Bowling scoring hasn't changed in 100 years. Roman numerals stopped changing something like 500 years ago.
Bit
Right,
longer, I think.
14 or 15th century Spain, as I think when the last innovation happened.
Oh, okay.
But it's much later than Rome, right? If we were actually being Roman about it, then it's much longer ago, right? Fibonacci was born 500 years ago, and so on, right? We're dealing with things that are static. Yes, if we have reasonable amounts of confidence that things like literals are not going to be changing on us, or if we are confident that the implementations that we are considering are not going to escape the module that is the context that they work in, I think there's a lot to be said for let's introduce something. My experience, however, is that introducing something like an enum
Oh, we've frozen. We're going to cut this part back out. Let's wonder a moment here.
There you are again. Okay.
There we go. We're going to cut that part out. The
All right.
Zoom
My
part.
connection was unstable. Fine. So one of my main touchstones, where do you start in TDD? What test do you write first? The first test you write is one that's easy to type. Get some momentum going, get the static friction broken, get going with it. If creating that test has a lot of extra ceremony because we've done things like lock down a bunch of literals with enums, we've made it that much harder, which is fine if there is a compensating benefit, but I don't normally see that compensating benefit early. And it really does depend a lot on the fact that we're building something against a static spec. Somebody comes along and says, we now want to deal with 8 compass points instead of 4. Can we just extend the enum? Well, that breaks a lot of comments or a lot of clients that were expecting only the 4 cases and don't actually have logic in them for the others.
How would that differentiate whether we had an enum or not? We could give it a string that had a 5th direction in it, and the client would break.
Because key idea here being now we're starting to look at, we're making changes to the contract. Right. What I'm trying to separate really here is I'm writing tests against an abstraction of the contract, not against the concrete implementation of it. Okay. And I want to be aware of if I'm changing the contract, that I really am changing the contract.
Okay. Well,
right?
Tell you what, go back to my feature file.
Okay. Let's find that.
That's down there on demo feature.
Right there. Under the
Okay.
screens. Yep.
And come up. Yeah. Okay. So there's there's my moves. Come on down to the directions a second. So excuse me, go back up. It's before that. Because it's
all right. Yep, north, south, east, west.
There's my test. There's my test for directions. It's independent of the implementation. You could do an enum, or you could have a class that simply accepts those four values?
You could. And honestly, I'm not entirely sure I understand what this lookup table is driving in our design. What insights is the lookup table giving us in our analysis? Right.
Well,
we've got this mapping of symbols to directions and distinguishing between, hey, this is a symbol and this is a direction. I think that's actually important, especially for the same kinds of thing happens with left-right move, right? They are operations or operation codes that signify operations in our interpreter.
well, I'll just suggest you have two different places where these strings appear. One in the operation and one in the parser. So now we've taken a symbol and used it in two different places. So if I was to add something, I'm going to have to add it in two different places. Whereas if I've got a single class that just contains these values and I add one, it's simply, oh. So on my input, I say, is this a valid instance of that class? And I don't have to care whether it's got 4 or 8 symbols in it. All of that is now self-contained within a class. It becomes a value object, if you will.
So yes, so there are at least 2, possibly 3 different concepts that I'm hearing entangled in there, right? One is the fact that these symbols are not arbitrary. They are part of a specification. You know, in this case, our make-believe specification for what Rover input language looks like. And that specification is a concept that, my opinion, we should be realizing in our model somewhere.
Right.
Okay, 1. So we're on the same page there. There is a second question, which is, should enumeration for languages that have it be the way that that concept is represented in the model? That's less clear to me.
That I will agree with. But if you either have a class that allows for those 4 instances, or you have an enumeration, or maybe even come up with
it might be a class. It might just be a namespace that is the specification, and it declares these symbols that you can access.
Yep.
We don't care what this. So yes, yes, absolutely. Should lots of the literals that we have in the implementation be pulled up into a specification of the namespace? Completely on board with that.
Okay.
Should the test cases be using that same namespace? Yes, for the most part, I'm on board with that. Potential conflict in terms of tension of reusing the names in the namespace versus tension of wanting to be able to type things easily.
Right.
Right. And certainly you could have a practice that says you type them in any way you want, but by God, before you check them in, you apply the machine refactoring that replaces the typed stuff with the symbols. Sure, great.
Yeah.
Right.
See, I'm yeah, exactly. So I think we're in agreement here. We know, we agree on the concept, and it all depends on
we
the
agree
concept.
enough to be able to argue with each other about it.
Right.
So that's we're 90% of the way there.
Yeah, yep, exactly. So okay, well, I don't think we've got time. We were going to do a few more, but I think that if somebody's looking at this and you'd like to see a few more refactorings, get in contact with either of us on LinkedIn. Just send us a message. I'm on just Ken Pugh. You can find me, Danil.
I actually don't know what my LinkedIn is right now. It's somewhere. If you search for DANIL, I am likely to turn up fairly quickly in the search results. There are not very many of us.
Okay, sounds excellent. Well, this has been a pleasure.
Thank you very much, sir.
All righty, thank you. Take care.